Before the Hyatt walkway collapsed, the danger was already on paper. Not in a way most people would notice, not with a giant red warning label, not with a drawing that said, "This detail needs another look before anyone stands under it." The plans looked like plans, the steel looked like steel, the atrium looked beautiful, and the people walking into that hotel in Kansas City had every reason to believe the building around them was safe. That is what makes structural failures so difficult to talk about. Because from the outside, everything can look finished. The lights are on, the glass is clean, the walkways are open, the space feels impressive. But hidden inside the details, one change can alter how force moves through a structure. One connection can carry more load than someone realized. One assumption can travel from a drawing to a shop detail to the field. And if no one catches it in time, the mistake does not stay on paper. It becomes physical. Steel bends, connections fail, gravity collects the bill. That is the room we're opening today. The Hyatt Regency walkway collapse was one of the most devastating structural failures in American history. In 1981, suspended walkways inside the Hyatt Regency Hotel in Kansas City collapsed into the atrium below, killing 114 people and injuring more than 200. This video is not about replaying tragedy for shock value. It is about learning from it. Because the Hyatt disaster teaches a lesson that still matters now, maybe more than ever, as artificial intelligence moves into construction, design review, document control, and engineering workflows. The question is not, would AI have magically prevented the Hyatt collapse? That would be too easy, and honestly, too arrogant. The better question is this: could AI have helped force the right question sooner? And if it could, what would still require qualified human judgment? Because that is where the real lesson lives. The Hyatt walkways were suspended inside a large hotel atrium. The issue investigators focused on involved the box beam and hanger rod connections that supported the walkways. The original concept and the final built detail were not the same in a very important way. The change may sound small if you are not used to structural drawings, but in construction, small changes are not always small. A detail can look similar and behave very differently. A connection can look reasonable and still carry load in a way that was never fully checked. That is what makes this case so important. The failure was not simply that someone forgot steel needs to be strong. The deeper issue was review, communication, responsibility, and understanding what a design change actually did to the load path. That phrase matters. Load path. A structure needs a path for force to travel safely. The weight has to go somewhere. People standing on a walkway create load. The walkway transfers that load to beams. The beams transfer it to rods, connections, columns, or supports. Every part of that chain matters. If one connection is weaker than the demand placed on it, the whole system can become vulnerable. And if a design change doubles the demand on a connection, or changes how that demand is carried, someone has to recognize that. Someone has to ask, what changed? Who checked it? What load is this connection carrying now? Does the detail still work? Was this reviewed by the engineer responsible for the design? Those are not small questions. Those are safety questions. Now imagine that same situation in today's world with modern software, BIM models, digital drawings, automated checking tools, and AI-assisted review. Could AI help? Possibly yes. AI might compare an original design concept with a revised shop drawing and flag that the support arrangement changed. It might notice that a connection detail is now carrying a different load than expected. It might scan drawings, notes, calculations, and revisions and say, this detail needs engineering review. It might help catch the gap between what was intended, what was drawn, and what was built. That could be incredibly valuable. Because many disasters do not begin with one person saying, gosh, let's ignore safety. They begin in confusion, in assumptions, in rushed communication, in unclear responsibility, in drawings that change, in details that move forward without everyone fully understanding the consequence. AI could help surface those gaps. It could act like a second set of eyes, not a licensed engineer, not the final authority, but a system that says, something changed here. Are you sure this was checked? And sometimes that one question can matter. Because the most important warning is not always a dramatic alarm. Sometimes the most important warning is a quiet prompt that forces the team to slow down. Look again. Verify. Ask who owns the answer. That is where AI could become useful in construction safety, not by replacing professionals, by helping professionals catch what busy people miss. Think about how many documents move through a construction project: drawings, specifications, addenda, shop drawings, submittals, RFIs, meeting minutes, emails, field reports, inspection notes, change orders, revisions. Now think about how many hands those documents pass through: architects, engineers, contractors, fabricators, subcontractors, inspectors, owners, project managers, superintendents. Everyone is looking at something, but not always the same thing, and not always with the same responsibility. That is where gaps can form. AI may be useful because it can compare information across documents quickly. It can help identify change details. It can summarize what shifted between revisions. It can point to missing review steps. It can help find conflicts between drawings and specifications. It can help organize the questions that need human answers. That is the good version of AI in construction. It helps qualified people see, sort, and manage information faster. But here is the line we cannot cross. AI can flag a problem. It cannot carry responsibility for the building. AI can ask, "Was this connection reviewed?" It cannot replace the engineer who understands whether the connection works. AI can compare documents. It cannot fully understand every field condition, every assumption, every code requirement, and every consequence unless the right people provide the right context and verify the output. That is the Build Smarter line. Use AI where it helps. Do not let it quietly become the person in charge, because AI has its own risk. It can be wrong in a way that looks right. And if you watched our recent video about AI drafting plans, that idea should sound familiar. A polished output can be dangerous because it feels trustworthy. The table lines up. The note sounds professional. The calculation looks clean. The summary feels confident. But confident is not the same as correct. And in construction, looks right is not good enough. If AI had existed during the Hyatt project, it might have helped catch warning signs, but only if it had accurate drawings, only if it understood the revised detail, only if the right data was included, only if the system was set up to compare the right things, and most importantly, only if qualified humans took the warning seriously. That last part matters most. Technology can raise a flag. People still have to stop. People still have to check. People still have to accept responsibility. The Hyatt disaster was not just a technical failure. It was also a human process failure. And that is why AI cannot be the whole answer. A better tool does not automatically create a better decision. A warning does not help if everyone assumes someone else handled it. A dashboard does not save you if nobody looks at it. A model does not protect people if the output is ignored, misunderstood, or trusted too casually. That is why the future should not be AI replaces engineering judgment. The future should be verified AI. AI with guardrails, AI with review, AI that supports licensed professionals, AI that helps teams see changes earlier, AI that helps project managers track open questions, AI that helps engineers compare revisions, AI that helps contractors avoid building from misunderstood information, AI that helps owners understand where risk is hiding, not AI as the hero, AI as the flashlight. Because when you open the room on a structural failure, what you often find is not one dramatic villain. You find a chain, a changed detail, a missed review, an assumption, a communication gap, a responsibility gap, a question that should have been asked sooner. That is why this case still matters. The Hyatt walkway collapse reminds us that buildings are not just designed once. They are designed, revised, reviewed, fabricated, built, inspected, and trusted. Every step matters. And if AI can help catch a dangerous gap before it moves from paper to steel, that is worth paying attention to. But we should not oversell it. AI would not have been magic. It would not have replaced the need for engineering responsibility. It would not have erased the need for clear communication. It would not have changed the fact that somebody qualified had to understand the load path and approve the detail. So the honest answer is this: AI might have helped force the right questions sooner, but it still would have taken qualified humans to understand the answer and act on it. That is the lesson. Not fear, not hype, responsibility. Because technology can make construction smarter, but it cannot remove the duty to build safely. And maybe that is the best way to think about AI in this field. AI can help us see more. But people still have to care enough to look. AI can help us ask better questions, but people still have to answer them honestly. AI can help us catch warning signs, but people still have to stop the work, check the math, and protect the lives that depend on the structure. That is not an anti-AI message. That is a pro-reality message. The goal is not to worship the tool or fear the tool. The goal is to use it wisely. Because a building is not a prompt. A building is a promise that the structure will hold, a promise that the details were checked, a promise that the people inside can trust the space around them. AI may help protect that promise, but it cannot be the promise by itself, and that is how we build smarter. If this helped you understand AI, construction, and structural safety a little better, subscribe to Build Smarter. We're opening the room on the tools, trends, and technology shaping everyday life, without the hype, without the panic, and without pretending AI is magic. Thanks for watching, and I'll see you in the next one. Keep building smarter.